So 12.4 talks about pyramids. We take a shift now from shapes with two bases to something with just one base, where the vertex is up at the top where the lateral area meets. So one of the biggest differences between prisms and pyramids is that prisms have rectangular sides and pyramids have triangular sides. And that's because pyramids only have one base, so they only have to connect to one side, so the other side comes to a point. So that's why they have triangular faces. So here's a pyramid. Before we go through, let's look at a couple things. If I draw a line straight down from the vertex to the center, that's the height of the shape. If I draw a line, let's use purple this time. If I draw a line this way, it still forms a right angle just like this one does, but they're definitely not the same height. The one going straight up and down is the height of the shape. The one going on a diagonal is called the slant height. Okay, so we have a slant height here, and we have an actual height of a shape. The one in green is going to come in handy when we're finding volume. The one on the side is going to come in handy when we're finding surface area, because we're looking for what's the actual area of that triangle. Okay, so first off, this is a square pyramid, so our base is a square. That's 16 squared, or 256. The lateral area, it's 4 triangles, so 4 base times height divided by 2's. This height here has to be the slant height. Well, that's messy. You know what it says, slant height. Okay, so 4 times the base. The base is the base of the actual triangle, that's 16. The height of the triangle is the line in purple. So since the base is 16, I can split that to 8 and 8, and this is a right angle. So 8, what, and 17 form a right triangle, and the answer is 15. So our slant height is 15, and we divide that by 2. So we're finding the area of one triangle, and then we are going to find the area of the actual lateral area by multiplying it by 4. So 16 times 15 divided by 2, and then times 4 gets us 480. So each one of those was 120, total was 480. We're going to add that to our base to get our total surface area, and our total surface area is 736. Next one, we're given the height going straight up and down. That's going to help us find our slant height. We need this slant height to be able to find the height of those triangles, to be able to find the area of those triangles. The question here is just asking for lateral area. So the 18 times 18 for the base is not going to be necessary here. 4 times base times height divided by 2. That looks like a minus sign. Let's change it to a multiplier. So 4 times the base. Base of each triangle is 18. The height of each triangle is this hypotenuse of this right triangle. Let's trace that whole right triangle. So when I look here, since this is 18, the apothem of that square is 9. 9, 12, and a third side form a right triangle. If you know your triples, you know that's 15. If not, you're doing Pythagorean theorem, you should still get to 15. Okay, 18 times 15 divided by 2, and then that's 135. There's 4 of those sides, so we're going to multiply by 4, and we get 540. So our lateral area is 540. If we had to find the total surface area, we would have to add the base, the 18 times 18. So example 3. The base is a hexagon. There's 6 sides. So my lateral area is 6 triangles, base times height divided by 2. So my lateral area is 6 times, since one of my bases is 8, my height is actually given to me. It's this line right here. It's the one that forms the right angle, and it's given to me that it's 20. So I don't have to do much work for lateral area. So 6 times 8 times 20 divided by 2 is 480. which means each one of those was 80. So if I wanted to find each one and then multiply by 6, it'd be 80 times 6. But now for my base, I have a hexagon. So let me get a hexagon out here. We have a hexagon where each one of the sides is 8. Here's the center of the hexagon. Let's draw my apothem and draw this right triangle. Since that's 8, this is 4. And the apothem becomes 4 square root of 3. It's a 30, 60, 90 triangle. We've already taken a test on that in chapter 11. So we should be comfortable plugging into the 30, 60, 90 proportion. So for the base, we're doing 1/2 apothem times perimeter. 8 times 6, which is 48. So 1/2 times 4 times 48 gets me 96 square root of 3. So my total surface area is my lateral area plus my base area. Now I'm going to leave it like that. The reason I'm leaving it like that is one has a square root, one doesn't, so I have to keep them separate. And my last example for this one, find area of one lateral face of a square pyramid where the surface area is 96 and the base has a perimeter of 24. So let's draw our square pyramid. Let's try our best on this. I'm going to draw my square just a little bit slanted. It's not even close to a square, but that's okay. Okay, kind of got the job done. Yeah, close enough. I know the area, total surface area is 96. And that 96 is the lateral area plus, whoops, not equals, plus the base. Alright, I know the perimeter of the base is 24, and it's a square. So 24 divided by 4 tells me that each side is 6. So the area of the base is 36. It was lateral area plus 36 now. Now, I don't have any information about the height or the slant height, so I can't actually find that. But there's 4 triangles forming the lateral area, and I just want to find one of them. Let's call it x. Subtract 36 from both sides. X is 15. Each triangle has an area of 15. Now it doesn't matter what the slant height is, it doesn't matter anything about it. All we're looking for is what is the actual area of that face.